Hello students, welcome once again to Solochem Lab. With me on the board today is a possible UTME problem to be solved. And the problem goes this way. We have a chemical equation, a reversible reaction, where copper 2 oxide is reduced by hydrogen gas to atomic copper and steam, that is water in gaseous form. And then a statement is made about this equation. The statement is this: in the equation above, the effect of increased pressure on the equilibrium position is dash. Some options are given. So we are being asked to say the effect of increased pressure on the equilibrium of this reaction going on here. What is the effect of increased pressure? First of all, in a chemical reaction, in a reversible reaction, for increased pressure or decreased pressure to have an effect on the equilibrium position, there must be at least one species that is in gaseous form. Did you get that? Look at this reaction. Do we have any species in gaseous form? Yes, the hydrogen on the reactant side is in gaseous form, and the steam on the right hand side, which is the product side, is also in gaseous form. So we expect an increase or a decrease in pressure to have an effect on the equilibrium position of this chemical equation. Do you understand? One more condition needs to be met before change in pressure will affect the equilibrium. That is, check the coefficient here. First of all, is this equation balanced? Yes, the equation is balanced, because let's check on the right hand side. On the right hand side we have one atom of copper. Then on the reactant side, one atom of copper. What about oxygen? On the reactant side, one atom of oxygen, and on the product side, one atom of oxygen. So copper and oxygen are balanced. What about hydrogen? 2 atoms here and then 2 atoms here. So everything is balanced. Is that clear? Now let's check the coefficients. What coefficient is here? 1 is invisibly present there. That's the volume of hydrogen gas used here. What about the steam? The volume of steam produced. What's the volume here? It's also 1 invisibly present there. So we said 2 conditions must be met. There must be gaseous species. Again, the volume of the gaseous species on the reactant side, which is 1 here, and the volume of gaseous species on the product side must not be equal for change in pressure to have an effect on the equilibrium of the reaction. Here, what do we have? 1. Here, what do we have? 1. Is there any difference in the volume, total volume of gaseous species? No. If there is no difference in the total volumes of the gaseous species on the reactant side and on the product side, that means a change in pressure will have no effect on the equilibrium of the reaction. Take it again. First, if there are no gaseous species, that means change in pressure will have no effect on the equilibrium. But in this case, there are gaseous species. So we have to consider the total volume of gaseous species on the reactant side and the total volume of gaseous species on the product side must not be equal if you want a change in pressure to have an effect on the equilibrium. But in this case, are they equal? Yes, they are equal. 1 and 1 there. Therefore, a change in pressure will have no effect on the position of equilibrium. Do you understand? And that brings us to, which correct option do we have there? Option C. There is no effect. No effect on the equilibrium. Whether you increase the pressure or you decrease it. What's the reason for that? Although we have gaseous species here, but their total volumes on the right hand side and on the left are equal. So we do not, a change in pressure will not affect the position of equilibrium. Is that clear? Do you still have more questions to ask about chemistry as you are preparing for your UTME? Feel free to drop the question at the comment area of this video, and Solochem Lab will be pleased to look at the question in our subsequent editions.